We are 4 after, so let's go ahead and get started. Thank you so much for putting where you're from in the chat. It's always fun to see where everyone comes to join us. I know a lot of you have seen my name in Handshake specifically. You are here, obviously, for Dr. Mike Rayo to hear more about AI. AI as an island. More specifically, I am really excited to hear about his conversation. But first, before he gets started, we want to just introduce you to AI Futures and what that is, because some of you may have never heard of us prior to your invitation via Handshake. So AI Futures is a funded program by the Department of Defense to help students like you find opportunities spanning from scholarships to internships and full-time positions. Because believe it or not, you can work for the DoD and not have to join the military. So thinking of different entities like the United States Air Force, the Marines, Space Force, which was newly created here in the past 4 years, and then obviously the Navy and the Army as well. So these opportunities are obviously worldwide, but we concentrate more on the continental 50 states. We work with in your geographic locations to see what opportunities are there. And then we go beyond that by providing you different student services. So we do informational sessions where you get to meet with one of our student outreach coordinators. We take a look at your resume. We give you tips for what that looks like on a federal side, because federal resumes are going to differ from your private sector. And then we have one-on-one relationships with different DoD partners across the US where we're able to forward your resume and get a different set of eyes on that. So really think of us as a different type of advocate for you. So how we're able to get in front of you, obviously events like these are technical talks. So we offer technical talks throughout the year. Most of them are going to be virtual. We are thinking about different ways that we can offer them in person. So definitely stay tuned to Handshake for any future events that may come across your path. And I will have a next slide here to talk about one that's next week. We do offer sponsorships for hackathons too. So if you participate in hackathons at your given university, we have been at the Ohio State University, we've been at the University of Georgia, Ohio University, we've gone up to the University of Michigan, Dearborn, Michigan State, so on and so forth. So we offer those sponsorship opportunities. We give more information about the Department of Defense. And really, we just love to see the different projects and ideas that are brought forth by the different student groups. And then we do provide our own type of events. So hosted events like AI ground vehicle challenges, where we provide our own robots, where you get the opportunity to bring those robots to life and take them through mazes. So really getting to learn different facets within coding and programming. So really just a well-rounded idea of what it's like to work within AI, but also learning of what it's like to apply that within your potential career or internship within the Department of Defense. So a lot of different things to explore within the AI Futures program. So talking what's going to go on beyond this Friday. Next Friday, we have a very interesting talk with the United States Air Force, specifically within one of their software factories called Bespin. So if you're a Star Wars nerd like me, you may recall that name, Bespin, but it does stand for the Business Enterprise Systems Product Innovation. This is going to deal more with your software development and app development. So if this is something that you are interested in, please stay tuned for that. The QR code on the screen is what you can do to register, similar to what you did for today for Dr. Rayo's talk. There is a Handshake invite that is actually, it hit about 8 minutes ago. So if you didn't get it, make sure you do scan this QR code. I can always put it up at the end of the talk too, if that's beneficial for you. But with all that being said, you're here for Dr. Mike Rayo. So very excited to have him join us for the first time today. I got to learn that he has had involvement with the DoD in his past. He's had involvement with the Navy, and then most recently, and in his current life, he has had involvement with the Air Force Research Laboratory, so who is one of our partners. So very excited for him to get his talk started. Just some housekeeping items. We we are going to have a Q&A session here at the end of his talk. So reserve any of those questions for the chat. I have Jawan and I have Matthew here who are going to be fielding those questions, and then we'll be opening that up. So we'll get through as many as humanly possible. So thank you so much. We're so happy that you're here, and I'll go ahead and pass that baton over to Dr. Rayo.
Great. Thank you so much, Jesse. Wait for this thing to boot up, boot in, whatever. Like Jesse said, my name is Mike Rayo. I am Associate Professor in Integrated Systems Engineering at The Ohio State University. I'm also core faculty in Translational Data Analytics. And I'm really excited to talk to you about potential future careers in AI, kind of what AI looks like from my perspective. And I think I might be giving you a slightly different take than some of the other tech talks, in that I'm a designer, and I am a human factors engineer, and I'm a cognitive systems engineer. So amazingly, maybe oxymoronically, I'm trying to put the people in AI, which doesn't sound like that should fit, but that's really what my work is all about. And so I'm actually going to extend a little bit of the work done by Matt Johnson, where he talked about designing AI as an island. I'm just going to take that a step further, and I'm going to ask you all, what bets are you making? And I'm going to use a set of stories to set the scene here. And I'm going to do that because AI shouldn't be seen as this kind of abstract thing that's just something we work on. It shouldn't be seen as something that's just happening to folks over there, or just hoping, just happening, in certain parts of our lives. If it's not happening to you, if you're not engaging with AI right now in a significant part of your life, well, you may be, even if you don't know it. And if you're not now, you soon will be. So I think it's worth it to think about, like, how does this and will this affect our lives? And so I'm going to start with my first story about one of my absolute best friends in college. So this guy had a running gag that doubled as a surprise life lesson. So he had a superpower, and that superpower was that he could get people riled up. And when he got people riled up, they would say all kinds of things. He would say something outrageous. They would say something outrageous. He would say something outlandish. And it would just escalate. And it would get to this fever pitch until eventually he'd get a little smirk, and he'd launch his trademark phrase. It's like, oh, I see what you're saying there. I'm not sure if I agree with it, but would you bet your life on it? Now, this was the moment of truth. This is when all the rest of us kind of, got our popcorn, leaned in, and said, what's this other dude gonna do? A real decision had to be made here by this other person in the argument, because if they said, no, I don't care that much about it, I'm not going to bet my life on it, then the argument was over. My friend would basically have won. Now, if they said yes, if they doubled down, if they said, yes, absolutely, I'm going to I would bet my life on this, then no matter what that topic was, no matter how impassioned my friend was about it, his answer was always the same. He'd kind of take a step back, he'd scrunch up his nose, and he'd say, wait, you'd bet your life on that? That's silly. This is stupid. Why would you bet your life on this? What if something changed? What if you didn't know something about the world? You never bet your life if you could help it. And that would get a laugh. But I started internalizing that, and actually I started using it in my teaching at Ohio State. And I use it because my discipline, cognitive systems engineering, is actually a lot of our findings kind of fly in the face of conventional wisdom. It's not just kind of face value of what's going on in the world. And this means that when my students come in, they have to learn new concepts, and they have to learn new concepts that are going to be different, conflicting with some deeply held understanding of the world. So this unlearning and relearning is and can be really painful. And so I try to inject a little humor. So one of those non-intuitive findings, one of those flies in the face of conventional wisdom findings, actually has to do with AI. And it flies in the face that AI is going to, or maybe it's just the next version of AI, that's going to fix all of our problems. And we actually started seeing that with the advance of symbolic AI a long, long time ago in commercial aviation and nuclear power in the 1980s. That's actually when my lab got started, the Cognitive Systems Engineering Laboratory. This idea, this thinking, actually, when it started there, it's popped up in new industries over the last 40 years, including healthcare, space travel, all through the Department of Defense, and most recently, critical digital services. Now, a lot has changed in the last 40 years, including what we consider AI and how we think about it. So AI has exploded into every nook and cranny of our existence, in our work life, in our home life. And there's really intense interest to deploy AI into every aspect of our work and life. So I get asked a lot, like, how is this AI different than other forms of AI? And there are lots of answers that I could use for that. But the one I tend to use the most is, this is the first time I've been asked about my work around the family dinner table or around the Thanksgiving dinner table. They asked me about AI. In fact, I was getting a really intense kind of PT session this morning, and the dude giving me my PT was like, "So, what do you think about this new AI? This guy who's an ex-power lifter. Like, what do you think about the next AI? Like, it's that attached into our societal fabric." So we encounter it in all these places and every day. So I want actually to get us in this next story. It's about you. So I want you to imagine you're escorted into a room and you see a newfangled gizmo that you're expected to use, and you know that it absolutely has to work. It has this logo stamped on the side. So I have a question for you. And I suppose you could put the answer in the chat, or just kind of, just answer to yourself. Would you bet your life on it? Now, I hope from my last story, you would know the short answer. You would know maybe the funny answer. However, when we're talking about AI, the slightly longer answer is knowing the answer to this question. And that is, how does it fail? And how well does it fail? Now, to illustrate this, and what are we talking about fail? How does AI fail? I'm going to share with you a video example. And it may look like I'm picking on a certain product, or it may look like I'm picking on a certain company. I'm not. I just happen to pick the failure that had the best video footage. So let's get into that.
To watch self-driving.
So I happen to agree. That technology on that day was certainly not up to that task. And so, it's not ready. But it's maybe not. Maybe it's not ready in a way that you wouldn't think. Because what we know is that all of us, at some point or another, are operating outside of our capabilities. In fact, we do it so often that we have innumerous euphemisms for it. For example, have you ever been in over your head? Have you ever been out of your depth? And what we know is, when given enough time in the real world, so will every AI solution. So what do we know about how well architected systems in high risk, high consequence, and high uncertainty domains address that very issue? What we know is that if you design for solo AI performance, failure will be brittle. And if you design for joint human AI activity, failure will be graceful. So let's talk about brittle and graceful. Brittle is what it sounds like. If you bend it, if you stretch it, if you stress it, if you put too much stress on it in one direction or another outside of its envelope of capabilities, what you get is catastrophic failure. And in material terms, that means it's unrecoverable. I want you to think about, peanut brittle, or maybe, smashing a chunk of ice with a sledgehammer. You're never getting that back. Now, by graceful, I mean that even though the function will degrade in the system, it will degrade slowly. It will not immediately decompensate. So think about like silly putty, stretches, and then it reforms. You can stretch it pretty far. Eventually, it may fail, but you can get it pretty far. Or maybe a paper clip, where you bend it a little bit, it bends right back into shape. You can bend it and kind of get it bent out of shape, and if you bend it back, it's not the same paper clip, but it still retains some of its functional abilities. So we want to go actually a step further than failure, graceful failure. We want to actually think about graceful extensibility. So if you do it well, if you architect the system, that is the people and the technology together, if you architect that well, that system will gracefully extend. It'll recruit resources dynamically and increase its capability to that new demand or challenge so that it can be managed. So how do we do that? And first, like what are some questions we can ask? We say, like, how do we know if this AI is ready for that graceful extensibility? So these are a couple questions that I literally ask every AI developer that I work with. They don't usually like them very much. So I ask them, how does that technology, how does the AI know that it's wrong? And then how well does it know it's wrong? How well does it communicate when it's wrong? And then how does it provide cues that it's wrong, even when it doesn't know that it's wrong? That is the absolute number one key here. And then again, how well does it do it? So we think about the things on the left, those are design strategies. I can answer all those with design strategies, but how well does it do that? I can only know that if I'm doing observation and evaluation. So I actually have to go do some kind of test. We shouldn't just take anybody's word for it. And so the other thing is with these second and third rows, this requires what I call self-explanation. So many of you may have heard of XAI or explainable AI, and most of XAI is focused around the machine or a machine providing an explanation to a human being. That is critically important. But what's more important is what is the internal mental explanation that the person or some other actor makes about that machine. So just because a machine delivers an explanation doesn't mean that that's the explanation that will actually be received or generated internally in the person. So what we care about is any mechanism that the technology has to be able to allow for explanation, explaining like the verb, not just the explanation or the artifact that the machine generates. So this is our matrix for initial contact with our AI developers. What of these 6 boxes are you playing in right now? The other thing we talk about is a joint activity architecture. Now, I don't expect that anybody on this call, well, some of you, I know your name already, so I know maybe you know about this. But if not, let's break that down. What is a joint activity architecture? So first, let's get into what's joint activity. So joint activity is a set of 2 or more agents. Those could be people, those could be technologies, those could be people and technologies working together to perform an activity. All right, what's an activity? So it will be very, very broad. It's something that is or has been done. Now, this actually draws from the French translation. So the actual work that is being done, which is the work as done, that's called activity, activité. Not the formalized, often distorted view from afar of that work, which is work as a management or tasks or tâche. So we're thinking about what's actually being done here. And now let's think about an architecture, and this is a broad term. It's the conceptual structure and logical organization of a system. So when I put those together, a joint activity architecture is a set of possible ways to organize how multiple parties can and do work together to perform an activity. What are all the different ways within that architecture that it could happen? Now, we understand in practice is there's intended JAAs. That's what's designed in the system. This is what the designers explicitly encode into it. But there's also the emergent JAAs. This is what actually happens out there. Now, an emergent JAA could just be a subset of the intended JAAs because the people in technology actually can't make their way into one of those configurations. Or it actually could be emergent and outside of that through some serendipitous process, some new configuration emerges. So there's lots of different ways to explain and describe JAAs. I'm just going to go through one dimension of that, and it has to do with how and how much deference one of the agents gives to another. So we're going to talk about how much people give deference or cede authority to the machine when it makes some kind of output. That could be a decision, that could be an action. With this first one, which is comply or override without support. That's basically take it or leave it. The computer said it's sunny. The computer is just about to stop the car in the middle of the freeway in San Francisco, and you take it or leave it. Do you go with it or not? So that means the primary giver, that's the machine at this point, it offers some output, and the receiver is only given that output and must make a decision. Is that a good one or not? And a big part of that decision is an assessment of the output's fitness. So how fit was it to do that thing that it did? How good at it? What kind of coverage? How capable is it? And most of the time, cows is the architecture that we see with AI. It's if you get an output, you may even get an explanation for it and like take it or leave it. The next architecture is an explicit support for override. This is where XAI comes in. So a secondary giver, in this case, the explanation AI, provides guidance for the fitness of the primary giver, which is the primary AI. So now the receiver has to make a fitness decision for both the primary and the secondary. How well was that first AI working? And how well is the second AI explaining the first AI? So it can all go just fine, but hopefully you can start to see that maybe there's some problems that creep up with this architecture. The third architecture is an implicit support for override, or ISO. And this is where additional information is provided outside of the primary AI, or the secondary, or the tertiary AI to give implicit support for the person's decision. So extra data, extra information is given to support that. So I'm going to go through a couple different examples of functions that are supported and some actual research that's been done at Ohio State to show kind of how this works in practice, or at least how it works in the lab. And before that, though, I am just going to go real quick. What we focus in a lot is that idea of machine fitness assessment. And that's the ability for an outside party, like a person, to assess the machine's fitness to perform the activity it's currently performing. So this is my first example. What you see here is an air traffic control map that was shown to a set of pilots, and it's the display for some proposed flight planning software. And pilots are shown the path. That's that green path. It starts at the plus and goes southeast through what looks like kind of a nasty weather system, which I know a lot of us are experiencing today in the United States. And so the pilots were given a few different versions of this. The first one, they were just said, okay, here's where your flight's going. What do you want to do? You can stay with this one, or you can sketch out another path. And when given given that task, depending on the study, somewhere between 90 and 100% chose this yellow path. This is the safe path. This is the good path. What's happening, you can't see it in this picture, but the storm is actually moving from west to east. And so this, you go back behind the path. Now, there are some issues with this. You can see it's quite a bit longer. So maybe if you could find a shorter path, that might be advantageous. But this is the path that all said and done is the path that we would expect and encourage pilots to choose. However, when machine guidance is added to this and starts to put in additional constraints like fuel usage, like turbulence, like total time in the air, the machine actually tended to choose this path. And when the pilots were given the machine recommendation first, and then asked, what would you like to do? You can keep the green path, you can keep the blue path, or you can sketch some other path. That 100% of folks that went the safer path, the more encouraged an appropriate path, that went down to 30%. Only 30% chose that path. The other 70 chose one of these riskier paths, either something right on the blue path or something very similar. So, this is actually the seminal research in the late 90s that giving this guidance is not innocuous. So let's go to another example. Here's an example in healthcare, and in this one, the machine is recommending a certain procedure, a diagnostic radiological procedure, in this case, a CT. Now, it's recommending a CT of the abdomen and pelvis with contrast. That means 2 CTs, quite a bit of what's called ionizing radiation. Ionizing radiation always carries with it a low risk of onset of cancer. And that risk goes up quite a bit for fetuses. And if you notice, this computer also doesn't think that this patient is pregnant, but the physicians actually do know that the patient is pregnant in this simulation. What we did here is we simulated a miskey in the data. So the computer has the fundamentally wrong mental model, says you need to give this CT to the patient. It is absolutely 100% never indicated to give this particular procedure to a patient, to a pregnant patient. And when given this advice first, even though this has all been trained into physicians, 50% of the physicians actually stayed with the computer's recommendation. However, when we gave an extra panel to them that gave, in fact, this exact panel, and even though it actually shows more, now the red boxes are mine, just to show you where to look today. But even though it actually gives you more information about why you should choose the CT. So the green boxes are what are called yield. That's how appropriate is the test. But it also gives the radiation risk, or the ionizing radiation risk in the nuclear signal, the nuclear circle symbols. So when armed with this information, but given the exact same setup, physicians went from 50% staying with the bad recommendation down to 10%. Now, we would love for it to go to 0%, but we're pretty excited about 10%. And from talking to these physicians, what they let us know is that they could actually see that there were 2 alternate modalities or alternate procedures that gave sufficient yield, sufficient appropriateness, but no risk. And so it could actually kind of see into the computer's algorithm and say, yeah, I understand that you want to go that way, but this way is better for my patient. So again, this interface, this representation really matters, and being able to implicitly or explicitly, in fact, both, that first one is that COWS architecture doesn't really say what's going on or how to know whether to override. This one gives that ISO. It's implicitly saying there's more data in here to say maybe you should override that suggestion. So what we're doing at Ohio State is actually trying to help AI designers and developers in a number of different ways. We actually start with these joint activity architectures, and we're starting to lay out what those look like. You saw examples of those today. We're also talking about design patterns. What are different strategies that designers can use in order to support the kinds of cognition that we need to support when AI is on board? So that's early into designs. Immediately after designs are thought up, we've developed a set of joint activity design and their JAD heuristics. So rules of thumb, much like user-centered design heuristics that were popularized by Jacob Nielsen in the late 90s, early 2000s, but those are for user-centered design. These are for joint activity design, specifically thinking about how to design with AI. And then we have actually developed a new observation or evaluation methodology called joint activity testing, which I won't go into detail today, but happy to field questions about if you have them, which is, again, specifically thinking about how does the machine and the person function together jointly relative to how they function apart, and specifically looking for that brittle versus resilient or joint gracefully extensible behavior. So that's how we're doing that from design and development all the way through testing and evaluation here in my lab, the Cognitive Systems Engineering Laboratory. So I wanted to show you some of the work that we're doing most recently. And we're back in healthcare. Now we're trying to help nurses understand the imminent risk of what we call patient decompensation. And there's a lot of stuff to go on here, and I'm not going to be able to explain it all, but we're actually using a set of let me see how to use my, if I can use my, okay, it's on cursor. Hopefully everyone can see my cursor. There's a set of annotations, which are implicit support, and there's this explicit support here as well. And again, this is a machine assist, an AI assist telling you how concerned should you be, what's the likelihood that they're going to decompensate or crash in the next 5 minutes, and then these annotations help you understand where the computer is the most concerned. And what we find is that whenever this red bar is on the screen, no matter what else is going on here, whenever this red bar is on the screen, it acts a whole lot like that first example in air traffic control. It's very influential. When it's right, it does well, and when it's wrong, it highly influences in a negative direction what the humans are thinking and deciding. If you only have these annotations on here, that effect is much more muted. But what we're finding is that the rest of this stuff, all of these other data, without the machine, currently in this setting is doing as good or better than when we're adding any of the AI support. So clearly we have a lot more work to do in these settings, and that architecture is going to be really important to get right. So I wanted to share with you, this is these words are changing a little bit. We're just about to publish these 15 heuristics, but it's in 5 different groupings. They all focus on different types of cognitive function that we want to support in people. So we want that to support event detection. That's what's going on in the world. Did I even detect it? Sense making. Can I make sense of it? Adaptability, or leveraging human adaptability. So limiting disruption, deferring to people, modulating participation. Joint perspective shifting. Can I actually pull somebody out of a perspective that is not advantageous and direct them to one that is more advantageous? And then the last are specifically about those human-machine coordinations. So explaining the decision-making, talking through what mode changes are going on with the automation, being very transparent about current computations. And then I'm gonna skip 14 for a second, but that 15, conveying misalignment, that's what we were talking about with the machine fitness assessment. How can we understand when the machine is having a bad day, especially when the machine doesn't know it's having a bad day? All right, I just talked through a lot. Hopefully all that has resonated with you. And I'm going to go back to our story. You're in that room. You have that gizmo in front of you. Now, maybe that gizmo is meant to help your physician make a really important diagnosis about you or a loved one, or maybe about a future procedure that you're about to have. Maybe that gizmo is about to fly you across the city, maybe across the country, maybe up into space. So the question I have for you is, would you bet your life on it? Now, what I'm hoping is that if it doesn't have this decal stamped right next to it, if it doesn't have joint activity inside, then you will curtly nod, turn around, walk out that room, close that door behind you, and keep walking. You absolutely should not bet your life on it. Frankly, you deserve better. So I would love to, so again, thank you so much for listening. Thanks to AI Futures for having me. I really appreciate this opportunity to connect with everybody. And I'd love to open it up for questions, discussion. If you see the QR code and our lab URL is there, please take a look. Do not hesitate to contact me, rayo.3@osu.edu if you'd like to talk more about this or anything related to it. Thank you.
Awesome. Okay, so we do have a couple of questions in the chat here. And then once we resume the chat, I do have, I'll throw back up our QR codes if you are interested in those informational sessions. And then I'm going to drop a couple of links just to give you guys a taste of what some DoD opportunities are like, and talk more about those too after we wrap up with Dr. Rayo.
Cool.
All right.
So I'll leave the QR code up for another couple minutes and I'll drop that down so we can get
Yeah,
the other stuff up there.
Absolutely. All right. First question. This is from Tania. Does this inform how AI assistance interfaces for further data retrieval and how it's how it's redesigned? I want to make sure I'm asking that correctly.
I'd love to be able to see. Is that?
Yeah, that's in the chat just a little bit up above.
Does this inform how AI assistance interfaces for further data retrieval? Interfaces for further data. That is a great question. So Tania, what our rule of thumb is that no matter what you're doing with the technology, if you've scoped the system without a human in it, then it's not, you haven't drawn your rectangle big enough yet. So even those places where, one way I could interpret your question is, oh, this is just about data retrieval. This is maybe baked down within the technology, and when we're starting to think about AI assisting with that, everything gets more complex. So if we have data retrieval that has a standard set of rules, like that's how I cut my teeth when I was doing database design and middleware design. I told the machine what to do. I told it how to join tables. I told it all those things. So now we're building. In fact, we're on a project right now with 16 groups across the country that are building what are called biomedical data fabrics. The biomedical data fabric actually is using AI to mesh these things together in ways that we couldn't do before. Fantastic technology that's going to, is going to unleash a ton of new breakthroughs and innovations. I firmly believe that. But if you think about the AI being that weaver of a fabric, I want you to think about it as a fabric and think about, well, maybe it misses a stitch. Maybe it introduces an artifact into that fabric. And maybe that artifact doesn't matter much. Like maybe when you're using that fabric, it's not stressed or stretched in such a way that artifact actually matters. Like maybe something is too tied together, or maybe it's not tied together enough. And I'm going to push on the metaphor maybe too much. But maybe that artifact, that abnormality, that defect in the fabric that the AI created, which is going to be very difficult if we're not explicitly thinking about how to detect those things, maybe that's critically important. Maybe that's where that fabric is going to be stretched. Maybe some diagnostic decision is going to depend on that part of the data fabric, and it's that part of the data fabric that's wrong, which means that one diagnosis or 10 diagnoses or 1,000 diagnoses are also going to be wrong. And so yes, it should. That's what we're stressing strongly to our colleagues in AI. But it's those places. There are a number of places where this kind of idea is not taking hold quite as quickly as we want it to, and that's why we're so excited about this project that we're actually doing with ARPA-H. That's the ARPA group for healthcare, kind of a cousin to DARPA. That they were excited about our thoughts about this because they saw the potential vulnerabilities as well. I hope that answered your question, Tania.
Awesome. So I'm going to kind of go all over the place with this next question because I think this might tee up a lot of other questions too. If you're allowed to share, what frameworks or languages have you leveraged in building out your JA models in your research?
So I could answer that a couple different ways. So JA is really a design process more than it's a development process. So we are pretty much, when we think about the development languages, we're pretty agnostic to what technologies you can use. So whether that's libraries, in a certain language or specific languages. It's also relatively agnostic to the type of AI we're talking about. So, convolutional neural nets or random forest models or something simpler like a which I wouldn't call AI, but it's in the same, well, I wouldn't call it AI, but things like multiple logistic regression. We think about not the technology itself or what it's written in, but because it's written this way or because it's this class of technology, what attributes does it have in order to facilitate JA? Like what relationships can it participate in? What kinds of activities can it actively participate in? Now, I can answer your question a different way as well. Say, what technologies are we using to do our JA work? And so we are, and again, I think that's probably, we're probably agnostic to that, but we tend to use R and R libraries to think about if we're doing our statistical analyses about evaluating that joint activity. And then, we, for the design, what technology are we using for the design itself? It's kind of whatever you got, so we're using a lot of HCD tools, or human-centered design tools, including pens and papers and Microsoft Axure and the other one, I'm just forgetting, but like literally anything you can do to get these ideas in front of people. That's what we're doing. And then we are specifying in a way that it could be built with a bunch of different technologies underneath the hood.
Awesome. Okay, and this next question is from Julia, and this sounds like just keeping JA relevant. So how would you help folks reframe the broad notion that unassisted AI will solve all their problems given enough time? Many programmers are working toward the idea of moving away from JA, and in fact might claim that JA isn't true AI or outdated.
So I would first point to history, and actually that doesn't usually work, by the way. But I would first point to history and say that AI and its predecessors have never been perfect. They've never been even imperfect in ways that are fully discountable. And that's true. And just no agent can be perfect. So if AI wants to get over that, and I don't claim that AI could never do this, kind of by itself, but it would have to be architected so it actually doesn't do it by itself, but it could figure out and effectively recruit the perspective, knowledge, task, capabilities that it would need dynamically, and that has not been done effectively. So that's the backwards or historically facing, which I am also a student of history here, and this is every time that perspective has been given to or directed to the AI community, they're like, well, yeah, that's just history, that's old stuff. Watch me work, watch me run, watch me go, and they go do kind of the exact same thing. So yes, things will continue to get more capable, and I think JA, the sweet spot is really in that place, and that's why I phrase it this way: would you bet your life on it? So if you're using AI, and I tend to pick on Google here, again, they're just easy to pick on. If you're using AI to direct internet search ads more effectively to people, and you send them the wrong one, now it's possible that you really could send them the wrong one and really negatively affect the life. That's possible, but the likelihood of in that setting is just not even in the same ballpark, not even order of magnitude as if we're trying to put AI on the flight deck of a commercial aircraft. If we're putting AI in ground transportation writ large and sending them out on our freeways, the stakes are much higher. And historically, as Americans, as world citizens, we don't accept people just randomly dying. We just don't like that. And so I actually I would maybe Julie and I need to be talking about what she how would she talk to AI about where that's going, because she's absolutely right. But we have lots of ammunition, and we're just trying to find partners that'll connect and be thinking that way as well.
Awesome. Sounds like she might want to talk, because she's also wondering what kind of papers and resources you would suggest to newcomers regarding graceful extensibility.
So graceful extensibility. So was one seminal paper which I don't recommend as the first entree, but graceful extensibility and joint activity are all based in what we call resilience engineering, and there's actually a set of videos that we've put together on what is important with resilience engineering, and maybe. Maybe somebody, I know there's some folks in my lab that actually could put the link to that site that shows all those videos. There's actually an interactive kind of video picker as well. if you get, maybe if I have a second, I could pull it up, but I think there's some other folks in the lab that maybe we'll put that on there as well. So that's where I would actually have everybody start. Is like, okay, what is resilience engineering? And with resilience, that's, graceful extensibility is a form of that resilience. So that's probably where I would have everybody start. And who knows, maybe I've talked long enough that somebody has, nope, not yet. So maybe if somebody in the lab would Slack me that link, I could put that. I could put that in the chat for everybody. Hint, hint,
nudge,
hint,
nudge,
nudge, nudge.
Awesome. Oh, Laura says she'll find it.
Excellent, thank you.
Awesome. All right, I love this question. How do you address the common criticism that humans are just too over-reliant on automation?
So from my perspective, what we've seen is that when a person relies on a technology and it fails, they're called over-reliant. And when they decide not to rely on a technology and it happened to be right, they're called under-reliant. If they wait to act until a machine tells them what to do or how to do it, and the machine is wrong and doesn't tell them on time, they're called over-compliant. Actually, I got that reversed. So there's also this idea of over-compliant, under-compliant, and what we try to do is really focus into the middle of that and say, how do people understand the fitness or coverage of other agents? And so we're actually digging into that with people trying to understand that with people. So there are a set of things that people look for, professionals look for, but that's really the key is there enough information in the world that a person can make an assessment? It's not about being over-reliant, under-reliant, over-compliant, under-compliant, because all of those things are retrospective. Those are all judgments after you know the end result. Before you know the end result, you have no idea. You have no idea if that person is being just incredibly efficient and effective with their time and they're using their tools and their teammates and everybody effectively, or if they're just being lazy. You don't know. And because they don't know until you see the output or the end result. So again, we're trying to focus people in, and we're actually trying to design for supporting that decision. How well fit is this machine to do what it says it can do, or to do what it says it's doing?
Awesome. We do have a Buckeye on here who's going to continue his master's, and he's wondering, is there a track specific to AI/ML?
That is a good question. I don't think that there's a track specific to AI/ML. We have AI/ML sprinkled throughout computer science, data analytics, and integrated systems engineering at the very least. And those are three kind of different looks at it. And computer science is actually folded into our data analytics major as well. And so that we have faculty across all three of those as well, across computer science, integrated systems engineering, and some sprinkled in a couple other places as well. So most of us think about AI and ML as an enabler to work of some sort. Again, the more foundational folks are going to lean towards cognitive system or computer science. The folks that need to know enough about it so that they can use it to do work, they're going to lean more towards systems engineering or maybe another major on campus.
Okay, awesome. So we are almost at time here, so I think we're going to end on this one last question, and then I'll boot back up our QR code. So again, if you're interested in the DoD aspect of things, and then I'll give a brief overview of some opportunities that are live now for applications. So Dr. Rayo, considering concepts like Moore's Law, do you think AI will ever advance far enough you would actually bet your life on it?
So Moore's Law, I mean, one, I think we've already cheated Moore's Law a couple times, at least once. I do think that things are going to get more capable. I do think that comes at a cost, just compute cost, just energy cost. but I'm going to double down. I'm going to bet my life on what I said, which is I'm going to be very wary, and I'm probably not going to bet my life on anything where if I know that AI doesn't have the ability to reach out for help, doesn't have a double checker somewhere in the process, or some other architecture so that it can, when it's having a bad day, I don't end up having a bad day. So to me, it isn't about the AI. It's never going to be just about the AI. It's about AI and people. And what I think we're going to see as we have more capable AI is that we'll have different configurations that we find are actually good for that work. So maybe that's not the definitive answer you're looking for, but that really is how I think about it. It has to be, if I know enough about that technology and they're not thinking about the joint cognitive system that the AI participates in, then I'm going to work tirelessly to fix that. And that's actually what I've done with my colleagues in ground transportation, with my colleagues in air transportation. I tell them I used to teach a industrial accident class. And I told them all, as AI was coming into each of their industries, I was like, I don't want to teach your accidents. So the ground transportation folks, like, I teach commercial aviation accidents and power generation accidents. I don't want to start teaching ground transportation accidents. I don't want to start teaching surface transportation accidents. And guess what I'm now teaching? These things are coming in. So that's where I'm at.
Awesome. Well, thank you so much for taking this hour with us. We really appreciate your expertise and giving a different lens on how to think about AI ML. So as mentioned, I'm going to go ahead and power up my screen again. Dr. Mike is very active on LinkedIn, so I'm sure you can follow him. He shares a lot of great insights there, so highly recommend. You can also follow us on LinkedIn to get future invites, future information about anything that we're involved in. You'll notice 2 different QR codes up here on the screen. Offers you 2 different, or actually technically 4 different opportunities to join some of our informational sessions that are coming up in October and November. We'll probably be adding in some additional dates here in the future as one of our colleagues comes back from maternity leave. But just to give you some flavor to what we're talking about as far as DoD opportunities, there are some applications that are currently open. I just dropped 3 different links into the chat here. The first one that you're going to see is the Smart Scholars Program. The application is open until December 1st. This is an educational workforce development opportunity for STEM students where you get full tuition, an annual stipend, an internship, and then guaranteed employment in the DoD once you complete this program and you complete your collegiate career. Really awesome opportunity. Highly recommend looking into that. The NREIP program that is specifically through the Navy, it is a summer opportunity where you'll get your own stipend. It is nationwide, so new undergrads, you get a $7,500 stipend. If you return for a subsequent internship, you get $9,000, and then graduate level, you get $11,000 as a stipend. They like to reward you in the DoD. And then the Palace Acquire program, that's through the Air Force. This is a program for anyone who has recently graduated with their undergrad or their graduate level. Within 2 years. It is a paid full-time training program that is either 2 or 3 years, again, offered to STEM students, but it does go beyond and more into the business realm as well. So after training, you are then offered employment as into the Air Force. So highly recommend looking into those links, seeing if any of those are of interest to you. If you are graduating either this December, next May, next June, and you're still looking for that full-time opportunity, again, feel free to reach out. We look at your resumes. We try to match you up with those opportunities. So use us. It's free for you. You get an advocate. Why not? So again, thank you so much to Dr. Mike. We so appreciate your time, especially on Friday. Happy last few days of September. Happy school life. I kind of miss it sometimes, but enjoy your weekend, and hopefully we'll see you at any of our future events.
Great. Thanks, everybody.
Take care.